All right, welcome everyone. This class, we're going to be talking about corpus linguistics. And why have I included a module on corpus linguistics when I'm trying to teach linguists natural language processing? So, the idea behind the class, if you have been following from series one, is that we want to teach linguists on how to undo data, on how to annotate data, and how to understand their roles in natural language processing without making them computer scientists. So you don't have to code before you can function as a computational linguist. All you have to do is to learn how to use linguistic instruments or linguistic tools that will enable you to function as a computational linguist or as an NLP, natural language processor. All right, so in the era of big data, what do we have to offer as linguists in the era of big data? And that is why I include the module on corpus linguistics. Welcome again. So what is corpus linguistics? Corpus linguistics can be defined as an empirical science by excellence since it seeks to reach conclusions based on the examination of external facts rather than on the linguistic expertise of researchers. So corpus linguistics is an empirical approach to language, and it is not really a field as some people think it is. Corpus linguistics is not a field of linguistics. I've read many texts that say it's an applied linguistics field. Applied linguistics, not really. In corpus linguistics, what we are going to do is that corpus linguistics is an approach to examination of language, just like we have generative syntax, generative phonology, generative grammar. That is how we have corpus linguistics. So corpus linguistics is like an approach to the study of data. So for me, if I will call it, I will call it data linguistics, which I'm working on something pretty easily soon. I hope it comes out soon. Data linguistics. So it is data linguistics. And what do we do here? We rely on the large amount of data sets to make predictions. So in corpora analysis, what we are doing is that we are trying to look for patterns. You know that when we are studying the basis of linguistics, we do data analysis, morphological analysis, try to ascertain the morpheme and the phoneme of the language, try to ascertain what is the stem in the language, the root in the language, want to know which word is what word in the language. We do that, you see that you were given a list of paradigm. That paradigm given to you is a corpus. So you look at it across different patterns to ascertain, okay, in this language is this, them is this, those is this, and you keep doing analysis. That is corpus linguistics. So corpus linguistics look at large amount of data sets and use that to make to get an insight to what linguistics is doing or to what people are doing about their language. And why is it important to natural language processing? All right. Why corpus linguistics? Big data. So in the era of big data, of course, there is a crux to saying that you only need big data. You don't just need big data, you need the representative data. You need a balanced data. So in corpus linguistics, we build data that are representative and balanced. You understand what representativeness means and what balancing means as we proceed in this course. Now, the aim of corpus linguistics is actually to provide structural analysis so that you can make grammar, just like you use Prolog. Prolog is a programming language that uses logic. And then it's just like you use Prolog to make some prediction in the data set. So is how you use corpus linguistics to make predictions. Now, structural predictions. I'm going to give an example. If you agree with me, if you especially in Africa, I don't know whether it happens in other part of the world. If you eat a food, if you have eaten and somebody asks, Samuel, what did you eat? And Samuel says rice and beans. That actually it's not just an answer to a question, it's an answer of quantity. You discover that what rice Samuel actually ate is rice and it is more than beans. So it seems that when the person ate something, if it is the answer you get or the choice of words is based solely on the it's based solely on the kind of answer the person wants to give in terms of quantity. So if you tell someone, what did you eat? Beans and yam. That actually means is we see beans as being more and yam as being just a top up on the food. If somebody say, what did you eat? Beans and potatoes. So the person has eaten beans in a large quantity and potatoes in just a top up. So structural prediction in corporal analysis is an insight to understanding the big data. So what will this do for machine? Machine knows that we have rice and beans because machine work by prediction, machine work by structural predictions. So such as simple as this may be, this is called actually called prompt and completion. That is, what did you eat? Rice and beans. The prompt is what did you eat? The completion is rice and beans. I think you need to visit our AYA project. I'm currently an ambassador at AYA, and we are working on building a multilingual data set for African languages, of course, languages of the world generally. And then we are using prompt and completion. This is what we do here too. All right, so this is why we need corpus linguistics in natural language processing. So let's now look at key concepts in corpus linguistics. This is where you will see why and how corpus linguistics is important. Concept one, we have concordance. A concordance is a collection of text that includes word use word use information in context. So basically, a concordance is the context where a word is used. So concordance is the technical name for sentence. If you tell somebody, what is the meaning of sporting? They say, I don't know the meaning of sporting. The person asks again, can you use it in a sentence? Why? Linguists actually believe that we don't learn words in isolation, we learn words in connection. That is why sometimes if you see somebody writing a misspelled word, you jump over it and pronounce the right one. Not because you didn't see the misspelled word, but because you didn't read the word individually. You read it in concordance. You read it in context. So you see, if you want to read, you pick like 2-3 words at the same time. You're not picking the word a concordance is a collection. No, you pick a concordance, a collection as one, and then you keep picking it in group. So concordance is technically the context of the investigation you are doing. Let's say you want to know, okay, if I ask 50 people, what did they eat? What the probability that they will give me based on the quantity. If they eat 2 combinations, what they will give me based on the quantity. So I'm looking for the quantities of, maybe I have rice and beans, right? You see that rice and beans is called heat. See heat, HITS in corpus linguistics, and heat is the word you are investigating. Heat is the prediction you are trying to make. Say, what would people say, or would people tell me based on the quantity of the food they've eaten, if they've eaten rice and beans, right? So if you look at, I picked a word from Kinyarwanda, Hano. Hano means here. So if I have a corpus of Kinyarwanda is a language spoken in Rwanda, it's the official language in Rwanda, and it's basically, so when I want to look for how many people tells me Hano here, how many people will tell me, I look at the concordance because the word does not exist on its own. People don't speak go, somewhere, eating, here. No, we speak structurally, right? Either by ideation as the Herbert belief or by structure as Chomsky believes. You can look at their own problem, but that is beyond this course, right? So concordance is what? Sentence. Thank you. So we have authenticity. So when a corpus comprises of authentic text, it means that the information comes from real text written in real circumstances. Pay attention to real text and real circumstances. So when we are building corpus, it's just always the case that when most natural language processors are trying to get data, they go on the web. Why? Because the web has like 60% of the web have a large data set and they are easily accessible. But you would discover that the web has only the language of news context, and we don't speak like we are casting news. Like the way I'm speaking now, I won't speak like this when I'm having a colloquial speech. And that colloquial speech is what we call authentic statement, authentic language. So, but you see that because many natural language processors are not native speakers of the language they are working on, they are looking for the news that is written in the language so that they can make precision with it. And they are having an unauthentic data. Why? It's just representing the news. So, and then another problem is authenticity is you discover that in the web, you have like web has 60% English language. Low resource African languages like Yoruba, like Hausa, like Kinyarwanda, like Kirundi, whatever language you're speaking, they are low resource because you don't have much data on them. So even if they're going to the news to get it, they can't even get large data sets. So we need to wake up as Africans or as low resource language speakers to be data set that are authentic in our languages. I think I have taught this in unit 2. I mean, in unit 2 on how to build data sets. You can check it out, how to collect data sets. Concept 3, representative. So it is not enough for your data set to be representative, to be authentic. It needs to be representative. Now, what do I mean by representative? It needs to achieve the goals for why it is created. For example, if you have to build a corpus of health, health domain in Igbo language, you must have words like patients, like doctor, like hospital, like syringe, like injection, like whatever thing they are representing. You must use the right jargon. You must use the right word. But you see, when you are in the news and you are trying to look at the health section, you are most likely looking at news about health and not necessarily a health conversation. It's not representative enough. In fact, you may be shocked that you never found words like patients nor doctor in your corpus. So, and if you don't have it, it means that what your data set is not representative enough. And representativeness is very crucial when you are dealing with corpus. Why? In unit 3, I think, if I remember well, we talk about types and tokens. I said types are independent or unique words in a data set. Tokens are the total words in the data set. I think we explained it. That unit 1 or between unit 1 to 3. And then types are new words in the data set. Tokens are the collection of all the words. And then the more you encounter new words as human beings, what do? The more we learn the words in the language. The same word for machine. So if your language or if your data set is not representative enough, your machine will not learn well. Why? It's just repeating the pattern he has been learning based on the tokens you have given to it. So your data needs to be representative. Collocation and co-occurrences. So what are collocations? I gave you rice and beans, right? So collocations are words that we most likely use together. So you can ask a question. Let's say you're investigating on what kind of English people speak in West Africa. And then you ask, okay, what is the probability that if I ask someone, ask someone, or ask someone, and ask someone to say ask, and they will say ask, or they will say ask instead of ask. Metathesis in phonology. So I want to say, okay, anybody that speaks English is most likely to say asks, and not ask. That's my hypothesis. Okay, and I say ask for, or ask of, or ask in. So what do we use ask for? In fact, do we really pronounce ask or we pronounce ask? Right. See, people say ask. They don't say ask. And then ask after. Some people don't know the difference between ask of, ask after, ask for. So how do we use these collocations? I'm asking for someone. I'm asking after someone. There are two different meanings, right? One is about the health state of the person. One is about looking for, right? So if I have this hypothesis, okay, this collocation, ask for and ask after, how many West African English speakers would actually use it in the right context? So my context means concordance. Remember, in the right context, what am I looking for? Ask for and ask after, which are the hits, right? I explained this earlier on. Hits are what you're looking for. Ask for, ask after are the hit. The concordance are the context where ask for or ask after are being used. So collocation just means words are used together and you want to understand the structural analysis. And then this is also important because um, machines don't learn words in isolation. You see how prediction is done in machine? It picks a word, map it to the second word, just like Chomsky predicted merge, right? Merging, like you merge. We predict it's based on probability. If I have ask, what of it that we have after here when this word is there? I ask after Samuel. I ask of Samuel. So if you teach machine to say, I ask of Samuel, I ask for Samuel, and I ask after Samuel has been the same thing, you are teaching machine wrongly. In corpus linguistics, our approach is that collocations do not have the same meaning. You really have to understand the concordances. That is the context where they are being used. So to build a data set, you have to create different collocations and different concordances. Lexical corpora. So lexical corpora, I think one time ago, I have this list of students I am teaching, or I don't know what to call it, and then I asked them to build a corpus of their language, lexicon of their language. So we have Igbo, Yoruba, Igbo, English, and like that. What they did was to build a lexical corpora. So just a list of words or terminologies in the language. They are called corpora. So a lexical corpora is a corpora that contains what? Lexicon. Lexicon means words in the language. So it can be a parallel corpus, whatever thing you want to think it is. It's just like a dictionary, you may say, not really a dictionary because it's not so loaded with pieces of information uh, like dictionary would be. Annotation. So the concept of annotation is labeling. We discussed data annotation in Unit 3, I could remember. Data annotation is the process of labeling data sets for machine to easily learn. So I'm not going to dwell much into that. You can check the videos for more insight. So when we have discussed the basic concepts of corpus linguistics, you want to ask, what are the types of corpora that we have? Remember, the reason for this is that we are looking at big data, and big data in terms of linguistics now is the corpus linguistics, right? Because at corpus linguistics, we are trying to look at big data sets. And I say your data set does not have to be, some people ask, what is the size of an appropriate data set? No, nothing like size. The data set is fulfilling the concept I explained earlier. Is the data set in a concordance? Is it authentic? Is it representative? So now you have a specific goal for creating a data set. Let's say you are creating a data set in the context of health. The goal is to have conversation in health, right? To have sentences, to have data sets in health. So because that is the goal, then you have achieved the goal if you can teach machine to understand data sets looking at the types. Now, what are the types? The word, the jargons, terminologies of the given domain you're working on. So not only about the size, but about what? How good data set is. So what are the types of corpora that we have? Okay, so we have parallel corpora. So what is a parallel corpora? A parallel corpora is a corpora that has or that have two languages, at least two languages. So you have side by side, you have English, you have Yoruba, you have Kinyarwanda, you have English. Two languages, parallel corpora. And then what is the usefulness of parallel corpora? Parallel corpora are used in machine translation. They are called machine translation data sets. Why? Because in a parallel corpora, you have two languages parallel to each other. So Samuel went. Samuel Yagi in Kinyarwanda, in Yoruba, Samuel Law. I think Igbo is Ogara, is it Gara? Samuel Ogara. So sorry, I can't, my Igbo teacher should pardon me anyway. But I'm just saying that that is the parallel corpora. So it has Samuel went, and then it has it in another language. So what the machine is going to do is going to teach the machine to map Samuel to Samuel, went to went in the two languages. Then it learns, okay, this one is this translated, this one is this translated. Well, Leviathan principle is also used here. And Leviathan principle is basically saying that what are the relatedness between two concepts. How later they add determine the size. So if you're doing statistical analysis, you're trying to look for, okay, when it tends to 1, what do you have? Don't really mind my explanation about statistical analysis, forget about it. But parallel corpora is just what? A corpora of what? At least 2 languages represented side by side. Thank you. Multilingual corpora, it's just the opposite of parallel corpora, but in this case, it is more than 1. It can be in theme, so you can have a corpus that deals with, where this one is different is, you can have a corpora that deals with health, tourism, oil, tourism, food, in different domains in English and Yoruba. But in this case, the multilingualism is not about the languages represented, but about what? The concept, the representativeness of the data set. Right. And then generally, multilingual corpora, of course, as the name implies, means it has more than 1 language. So Rwanda, English, Swahili, French, Yoruba, everything put together. So you would have a speech, a sentence in English, in French, in the same sentence in Kinyarwanda, in Swahili, in Igbo, in Hausa, parallel together. They are called multilingual corpora. So monitor corpora, a monitor corpora is a type of corpora that is ongoing. So when you are building a corpus, some corpus are actually not ongoing. It means once you have achieved the aim, you have achieved the aim. Let's say you are trying to build a corpus of a domestic, you are trying to domesticate domain-specific data sets. So you're trying to build a data set for health, and then you have an idea of saying, okay, I want to build 5,000 sentences, and then I'm going to divide it into different things like train data set and a test data set. I think I will explain that next week. So you have to build the data set, and once you are up to your threshold, you are done. But when you are building a corpora that is for general purpose, it has to show health, different domains. They are called monitor corpora, and they will keep going. You cannot finish. In fact, as big as English is, people are still building corpora on it. So a sample corpus is just, as the name implies, it is stagnant. So let's say you want to get the corpus of 2023 election in Nigeria. That is a sample corpus, and it is just for a specific goal. Once we build that, at that particular portion, all about 2023 election, you have a sample corpus. Maybe you want to use it to make predictions. Say, okay, every candidate comes from this particular political party will win based on this and this and that, depending on the word you're working on. That is a sample corpus. Raw corpora. So a raw corpora is a corpora that is it is got from the web. It has the tags. It's not clean data set. It's noisy. It can be a raw transcription, because if, for example, if you export your data set from Pratt, you discover that it has the time alignment, it has the annotator, it has a lot of information that you don't need to build to build your model. So that case, you have a raw corpora. A raw corpora has not been processed. It's just the way it has been exported from either the website or any platform you are using to build it. So generalized corpora, as the name implies, it's an overview of the language, and then it is a corpora that is built to do what? To represent every domain in the language, every domain in the language. You can crawl the web for it, whatever thing you can think of. It's just a generalized corpus, and it gives a broad overview, what people call large language models. Large language model data set as a data set that is big enough. It's very, very big. So specialized corpora. So a specialized corpora, as I talk about, is just a domain-specific data set. A domain-specific corpora. It can be about health, tourism, education, whatever thing you can think of in a specific domain. That is called a specialized corpora. About medicine, about linguistics, about natural language processing, about whatever domain you are working on. That is a generalized corpora. So if you are building a data set for teachers or education, corpora, you must see what like teacher, like pupil, like chalk, like marker, like board, like chair, like table. See, those words must be there, representativeness. Remember that? So back and forth, these are the types of corpora. And then we have annotated corpora, this one that has been annotated. So just like annotation we explained earlier, annotation is labeling. So a data set that has been labeled is an annotated corpora. So for example, if you are doing supervised learning, we explain supervised learning with one. Supervised learning is a situation where you supervise the machine to learn. So you give the machine a data that has been annotated so that then you give it another data that has not been annotated so that it can learn from the one that has been annotated and apply what it has learned to the new one that has not been annotated. That one you are given to it is called an annotated corpus. So I want to talk about Rwanda here, but I'm just gonna leave it. Just forget about it. Just look at how do we build a parallel corpus for a language. You select the language, you identify the domain, you collect the data, you align the text. It's very simple. You select the languages. So if you're building a parallel corpus, let's say I want you to be English and Kirundi, English and Yoruba. Okay, I want to move from English to Yoruba, and then I identify the domain. Am I working on a domain? Is it health? Is it tourism? Is it whatever thing I'm working on? Then I go collect the data set. I've talked about this. Then you align the data set. Alignment means you put it side by side in a Excel sheet. So you say English, Rwanda, English, Rwanda, English. So you clean the corpus. So if you have tags there, you remove them by find and replace. If you want to find and replace, you find and replace. You can clean the corpus. You can format it. Formatting just means alignment too. You validate it. So you give it to somebody to validate. Is this really representing the language enough? Then you publish the corpus. So what are the sources of parallel corpora? So you can crawl the web, you can use translation memory, you can use parallel corpus, parallel text in bilingual books, you can use government websites where you have both the English and the local language, you can use news outlets, you can crowdsource. So crowdsourcing work by using maybe a Google Sheet link. That Google Sheet link will be used to technically uh, to get the languages you are working on, to get a translated form. So for example, if I'm working on Yoruba, I can create a Google Doc, I will put the sentence as the question, then I will put the answer as the target language. So the source language will be English, which will be the question, then the target language will be the answer. So when I give it to people to crowdsource, they translate the sentence they have as in the question, and their answer will be the translated form of the question. So guide to use web crawler. I think I'm gonna run this myself. So let's keep this. So we skip this and then so how do we use this just demo? I'm gonna put it in the chat if you want to try it out. I think at the time I used it somewhere. So if you were in that meeting, you will get it. So this, because we are not developers. We want to get data set. So we can equally crawl the web to build corpora. So I will expect us to build at least around 500,000 sentences for our languages. How do we do it? We can look at BBC, BBC Yoruba, BBC, let's say BBC Yoruba, I speak Yoruba. I want to use Kirundi or Kiruanda, but I think Joven will be very happy. For now, don't let us use Kirundi.
Gahudza.
Oh, okay. So I'm gonna pick a news. So if I want to crawl the web, I'm gonna copy this news, the link to the news. I'll go back to the just text demo. I'm gonna click inside the URL. I'm gonna paste the link there. So you can actually decide to choose your language. It doesn't really matter much, although it works for some websites if you know the language. Unfortunately, I think Kirundi, Kinyarwanda is not here, sadly, but because it can't stop you from using it. Even though Yoruba is here, I'm not going to select any language. So I'm going to keep it open so that should it be that your language is not represented, you can still use it. So I'm going to click submit. Now you see, you have two things here. You have the orange. You see the orange color, is it pink? Something like that. Then you have like the green lemon color. That pink, baby pink or orange pink color that you see here um, shows clickable links. So you don't need them. Of course, it's just the header. Basically, they are called the headers. So I can hide the boilerplate. If I hide the boilerplate, it's going to hide those ones that are the boilers, that are the headers, and then give me only the content. So I'm going to hide it. Now you see, I have this content. So I'm going to copy it. So I'm going to copy it, and I'm going to open Google Doc. So I'm going to open it and open a Google Doc. I want to show you how to uh, sorry, I'm trying to open the Google Doc. So I'm going to go to File. So so I can keep copying them here, right? So I'm going to copy. I'm going to paste it here. So you see, it's not giving me what I want, right? It's giving me with the color. So I can remove that. I can go to channel, paste it here. Once I paste it there, I select it again, cut it, go back there. It's gonna work now. Paste it. You see. So I actually advise people to put it in text files, so you don't have to worry. Uh, so let's say I'm gonna pick another one. I'm just picking them randomly. Copy the link, paste it here. Control select, Control paste. Click submit again. Hide the boilerplate. Then copy this. So copy it. So you make sure you hover away from allowing this to show. You see this small box showing here. If you copy like that, it's going to repeat this one showing outside. So you click, you use Control C. So yeah, it's repeating the same thing the other time. So we're going to put it here. Back here. See, this is just, I mean, it's just building the corpus. And then if you use a plain text, it becomes pretty easy and simple. This is how to build a corpus. So let's go back to our studies. I was just trying to explain how to use the uh, how to use the how to use this web crawler to build a parallel corpus. So now we're going to conduct an analysis using AntConc, and I'm going to show you how to use collocation, KWIC, just a basic introduction of AntConc. So here is AntConc. So AntConc is an application developed by Lawrence Anthony. It's a powerful tool and it is used for corpus analysis, at least as far as I know. There is also Lanxbox, developed by University of Lancaster. It is used for corpus analysis, but generally AntConc is mostly used for general analysis, right? So how do you really start using AntConc? First, you go to File. You want to open a quick file, so you want to open your corpus. So basically you want to load a corpora file in it and or a corpus file in it, and I'm going to be I saved the content we crawl from the web. So this is class sample. Actually, it can be in plain text or PDF. So you just hit OK, you don't have to mind it. So I have loaded my corpus here. Now I want you to pay attention to something. So look at after I loaded my corpus, the file is I loaded just one file. The tokens, remember we have types and tokens. The tokens is how much? 673. And if I load the file, it's going to tell me the number of types. So I'm going to go to File, View. So I'm going to click the file. And I'm going to hit Start. So I can't see it. I'm going to click Start. See what it did. Now look at it. Here, you see that we have 5 types. So the types in the data sets are how many? 299, whereas we have 673 tokens. So what is the implication of that? The implication is that your machine will learn only 299 words. I repeat, machines in this data set, even though it is 673 tokens, machine will only learn unique words that are what? 299. So let's say we want to begin to do annotation to now KWIC means keywords in context. Let's say I want to look for the word. This is the heat. Remember the word we are searching for is the heat. You can see here we have all heat. And once I search the word here, I'm going to click, once I type in the word here to search, I'm going to click start. Now, I want you to pay attention. So you see that I search for the word Toby, and then we have Toby, and to the right, we have Amusan. Then we have 3 words painted to right. We have the one in red, the one in green, and the one in purple. Now, what this actually means is context. So it's saying we have the right context, we have the heat, and we have the left context. The left context is what words actually occur before the heat. The right context is what words occur after the heat. And remember I told you about heat. Heat is the word we are searching for, right? So if I want to really if I want to know, okay, how do I set the context? I mean the left and the right context. Now, if you look downwards here, you will see that we have sort 3 right, 2 right, 1 right. So it sorts the 3rd word, the 2nd word, and the 1st word to the right. If we want to change it, we're going to change sort option. We can click sort to the left. So 1 left, 2 left, 3 left. So I'm going to click start again. You see, what we have is we have words that are occurring before the heat. So why do we really need this? We need this because we want to know the context of its occurrence. We want to know actually what words come after and before it so that we can make predictions. Remember I told you about the prompt and the completion about question and answering. All right. So this is just one way to do analysis. Now, sometimes you may want to you may want to get the words in the language. So here, you want to get all the words in the language. You can click start. You see, and then you really want to do frequency analysis. This is very crucial to build data annotation, to build data sets, and to teach, to build corpora and to teach machine languages. You want to submit some pieces of information about the data set that you built. So you explain to your client, okay, this is the number of tokens we have, this is the number of types we have, and then this is the analysis of the word. Now, if you look at page size here, this page size is meant to restrict the number of things you see per time. You see, it shows 100 hits. Remember hit? What we are searching for, the words. So we want to say all hits. So we want to know all the words here. Remember, it was how much? It says we have 299 types. If you remember, we have 673 tokens. But you see that what we are having here is that we are having a 285, not 299 token types. So which means something is wrong somewhere, right? So you will have to figure it out, which is beyond this course. It's beyond this. This one is just an introduction to corporate analysis. So if you want to, you may want to copy this to show to your client. You click this button here. You see that place, or you Control A, then you Control C. You can paste it in a Word document, in whatever things you want to do. You can paste it anywhere you want to paste it, so that people can know what you are working on. So another thing I want to show you about, so let's say you want to create types. Remember, let's say you want to create types with your data set. Now remember that when we are sorting the words, what we are seeing here is by frequency. So the highest word here with the highest frequency is T, which has 26 frequency, right? So you can plot this. So you can look at a plot here, and then you can start. So let's say we want to look for T, right? Because T has the highest word. So we can click start. So we want to look at the plot, and you see this is the frequency, this is the dispersion, this is the plot. So you can copy it, click here, you can copy the plot. So once you click here, you copy everything, and then once you click the word, it shows you the file view, and actually shows you, if you double click on it, then let me go back here. If you double click on it, the plot, or you double click on the word, I think it's gonna show, it should show you the context. It's not working. So let's use here, really. Okay, yeah, you double click it, it's gonna show you the locations where the word is used. Now, as I said earlier, you will see that we have just 285 words. But whereas it tells us that initially we know that the number of types that we have, that's the number of unique words that we have, is 299. So how do we really check? We go here, sort by, and we click type. So once we click type, we click start. You will see what we have. We want to see the types in the data set. Now, invariably, we have the same type. So the question is, where did it get the first analysis? So it's always advisable that you don't use that initial judgment for your analysis. You use this one, because this one is going to tokenize it, break it into token, and give you unique word. So here, if you are building a data set that is lexical corpora, you can use this. So it's just lexicon, you automatically put it here, and it automatically creates the lexicon for you. So let's say you are creating a data set in health domain. You go to the web, you get the corpus, you crawl the web for like 500,000 sentences in health, right? So you make sure you are in health, you crawl the web. So when you build the corpus, you go here, you put it in Word, you generate the type, so that when you generate the type, then you use the type to create the sentences that you want to submit to your client. So I think I've explained this in Unit 2 concerning how to build corpus. So these are just basic analysis to do in corpus. Thank you so very much. And then I want to take your questions. So do you have questions?
Yes, I have a question.
All right.
So you have all these types, And but for building a lexicon or a dictionary, how do you filter out the infinitives or basic words for each type? Because you will have the different verb forms in this analysis, don't you?
Right. Fantastic question. Thank you so very much. All right. So there is something we call wildcard. So I'm going to go back to Corpus. So let's say in Kinyarwanda you say kugenda, nda kugenda. Like I am going, kugenda is to go, right? And then I want to pick to go. I want to search for it. So I want to look for K, ku with any other combinations. So you use wildcard to show that. Let's say I want to know the combination of T, letter T, and other things. So I'm going to put T, I'm going to put a wildcard. What is a wildcard? A star. Look at it. So what this simply means is letter T and any combination. So this way we can know what is what. So we can sort. So custom sort. I'm going to use custom sort. I'm going to click start. Now you see what we have is we have to, we have T, we have T, to, tun, TUN, TT. Now this one is meant to use its regular expression, right? But this is just one of the regular expressions. And then it means the typing you give and any other combination. Let's say you don't want any other combination. You want, let's say, T and any other combination. So TI and any other combination, you go back there, you click start. What you see here is TI. You see we have T T T T T T T T T T like that. Let's say you want TO, TO, and any other combination. You see, to read, to read, to be, to like that. Let's say we have AM and any other thing S. Now you see that when I created it, I put another letter after it. It's not going to work. So, but there are different expression I could use, but it's beyond this course. Let's stay with this. Now we have AM, Amuson, like Amuson, like Amon, like these are just the eats that we have. So I think this one can let you understand the root word and the stem word, depending on what you're working on. Did I answer your question? Maybe.
Halfway.
Okay.
Because when I want to search for combined words like all the verb forms of one verb, is it possible?
If I want to search for all the verb forms of the word.
All the verb forms from kugenda.
Okay. Yes. If you say kuje, sorry, sorry, I don't have Kinyarwanda corpus. But let's say we have verb form giye, ya izi ya giye, ya giye, like gi, but invariably you have gender, right? Go, then you have the infinitive from kugenda. Right? So you can, if you look at it, you see that what is very common to this is the G, right? So you can look for G and any other combination, examine it and see what you have. You know, this is not, so it's gonna give you every possible combination. So now, if you want to sort it, you may want to sort to center. Let's say sort to center, right? Now click start, see what that gives us. You see? So I can sort to center left. See what that gives us. You see? I can sort to custom. I don't know why this custom is supposed to bring both sides. This has changed. This is the latest version. All right, so yeah, this is one. Then you want to look for, maybe you want to use for collocate. So you click this. So you don't have a collocation. Let's say you have to be. So if you want to look for verb patterns, now sort by likelihood, type. Oh no, no. So will be this. I don't know why it's not showing. I see, I see, I see. So yeah, you can use collocation, but it's not showing here. I don't know why. But these are just little things you can do. You just have to tweak it and use it for your own analysis. And then of course it depends on the language you are working on, and it depends on. So the essence of the heat is to tell you what you are searching for. I explained earlier, I don't know whether you joined late, that the heat is what you are searching for, the word you are searching for. That is the heat. Yeah, you're welcome. All right, so you can do different things here. If you are working on a data set, you want to know the number of types, you want to know the word frequency, you want to know the stop words. In the language, you can use just this, like you can search for the words, then you can do the analysis by yourself you can copy this here, paste it there, check out for the stop words. If you are trying to create a word list, let's say you want to use a word list to build data set for Igbo language, you don't really have to, you have to collect a natural data. So you do this by, okay, can this software annotate? Yes, we have what we call tagant. It's not this. This one I'm doing here is just the basic analysis. So yes, we have tagant. Tagant can help you to do part of speech tagging pretty well. And just like you feed your flex, the one we did last week with data set, and it learns from it without you teaching it, you can teach tagant too, and it's gonna learn, and then you use it to tag. But this particular one only does not tag. It's just for investigation, types, tokens, stop word frequency. Then additionally, you know that stop words are tag and tag. If you download it, you can download it, tag and. So I'm gonna share the slides. I'm gonna share the link. We have a WhatsApp group. I'm gonna share the link to the meeting. It is recorded, so I'm gonna share it. Do we have other questions? By the way, in corporal analysis, functional words show more frequency than content words. Why? Because we need functional words more than the content words, whereas the content words carry the message than the functional words. What European languages call functional words, they call them as top words, but in African languages, they are very important. I remember somebody sharing a scenario of a chatbot that we built, and then the person said that when he went to give it to the client tested with an exclamation, aha. You know, if you are speaking to someone in Africa, we don't keep quiet most of the time. They say, yeah, yeah, and then we say, okay, the chatbot is working, and the person just said, and then the chatbot does not know what we're saying. So, yeah, it can be like that sometimes. So Do we have further questions?
Yes.
Okay.
Yeah, thank you for this wonderful presentation. In fact, I'm happy to be part of the class today. This is my first time. And but with my little knowledge of NLP, I've been able to cope with the class. I really appreciate it. Now, I want to ask a question as regards, can this linguistic analysis be used on novel data set that is on speech?
Speech data
Maybe
set.
like, yeah,
You mean
I
speech
have speech,
corpora, right?
yeah, speech copra.
Yeah,
I
we did
have
something
speech
like that in.
copra and I have test copra that I asked some of my research assistants to create, and about 500 rules. So I want to know if we can actually use this to work on it for a question answering system.
Okay. So first, we already taught in the first, I think the second week or so, we talked about building speech corpora and how to build it using Pratt. You can get the video, it's on YouTube. So AntConc actually work with textual data sets first
Sorry,
to
I didn't
start.
hear you. Hello?
Yes, I can hear you. Can you hear me? Can you hear
Hello?
me? Yes, I can hear you. Can you hear me? Yes, I can hear you. I can hear you. Maybe your network, I'm not sure. But I can hear you. Can you hear me? Favor, go and look for it. Thank you. You were here. Weren't you here, Favor? Weren't you weren't you here when we did the unit two? Just look for oh, I'm gonna share the link. I'm gonna reshare the link on the WhatsApp chat then. Oh, I thought you were. Can you hear me now? Hello? So, just to answer your question, I taught how to use build speech corpora using using Pratt, how to do speech-to-speech annotation, text-to-speech annotation, using Pratt. I think we discussed that a few weeks ago. Uh, that is that. Then to use AntConc to build question and answering system. Okay, I think what you can do is generate your data set using the speech, using the web crawler I taught. Let me go over the web crawler again. So you don't have to code. You can use the free web crawler without coding. Let me share it again. So here you have the web crawler. So let's say I want to build question and answering system using news dataset. So I can click a news. Let's say I want to crawl this news. Somebody's typing. Okay, I'm gonna type it there. I'm explaining something, please. All right, so I'm gonna click this. I'm gonna copy the link. I'm gonna put it here. I'm gonna put the link here, paste it. So I'm gonna click submit. It's gonna crawl the web for me. Yeah, so I'm gonna hide this, and then this is the data set I want. So I can just use this data set. Once I copy it and I paste it somewhere, so these are the corpus we generated the other time, the frequency analysis. Uh, so I'm just doing a test. Remember, if I copy it directly, it's going to retain the color. So I'm going to find a way to remove the background. So once I crawl the web and I got this, so what I can do is I can all right. So I can generate the news. So once I generate the news, So once I generate the news, I can put it in corpus like we in AntConc, like we did the other time. Then I can generate the words. So, I generated it by type. I can generate it by frequency. This time around, I'm looking at the stop words and stuff like that. I told you functional words come before content words. They have higher frequency. And this is a normalized frequency. This is a normalized range, depending on statistical analysis you're working on. So once I generate this one can give me the word count. And then I can use this word to generate questions and then generate answers without thinking about the word, because it becomes easier for me to generate sentences using using a given list of words. I mean, easier to generate questions using a list of words without necessarily learning the words one after the other. That is about question and answering. But AntCon cannot in itself generate question and answering for you. Now, concerning the speech corpus, I said, I should type here, it is Pratt. Pratt. That is it. Speech corpus builder. And then, mind you, Pratt can do a lot of magic. Especially if you are doing automatic speech segmentation or whatever you are doing, you can use script to do it, and then that is that without code, and it's pretty easy and pretty straightforward. Do we have further questions? The time is fast spent. We spend more than what we used to spend. It's a bit engaging. Okay. In the absence, no other questions. Thank you so much for coming. I'm going to stop. We'll meet next week for the last class, hopefully.